Um, hey guys, I got a new glowscript video for you today. What do I have? I have a hollow cylinder with a rod running through the middle of it. So, let's get into it. This is K. This is mu 1 over 4 pi epsilon naught. This is the charge of our cylinder. It's going to be uniformly charged, and our uniformly charged rods. I gave them the same charge so they would repel each other. This is the scale factor for our arrows, the length of the cylinder, the length of the rod, the parts of the cylinder, parts of the rod, radius of the cylinder. I made the rod exactly the same way I made in a previous video, and I just built a cylinder around it. So this is our observed location here. This is the stuff for our rod, our integral, and this is our integral for our cylinder. So this is just doing the electric field for our rod. It's nothing special. This is building our cylinder right here. I had a lot of trouble originally because I was building quarter circles and half circles instead of a full circle. So after a little while, I figured it out. My professor helped me out a little bit, but I eventually got it to work. But this is calculating our electric field for it. There's a small issue with it, and I'll explain it to you in a little while. But this is pretty much it, and the electric field, the net electric field is just the sum of the two, and this is just arrow stuff. But let's run this. So here's what we get. So there's a little bit of deflection to it because I integrated this along the y and z axis because it's actually like this. So it's integrated along the y and z, and then the rod is integrated along the x-axis. So this is the electric field for our rod right here, and this is the electric field for our cylinder right here. And then this is the sum of the two at the observed location. So I don't know why it's slightly off center. I mean, it's just, I mean, it could be any number of things. But even as I move this further out, it still has that slight angle to it. So I'm not entirely sure. But let me explain to you like why I don't think this is correct. Not only because when I integrate when I make a cylinder, it's going to be a little weird around the edges, especially if it's uniformly charged. But when I run this program, this is the program almost exactly the same as the other one, just specifically for the cylinder. So when I run this, yeah. So just at the center, it should just the x and y components should cancel totally, giving you just the x component. But as you can see here, it's still deflecting a little bit to the side. And I'm not entirely sure why. So I'm not sure, but as far as my current calculations goes, this is going to be our net electric field at this observed location due to the rod and the cylinder. If it was just the cylinder, it's just going to be this. So, alright. Well, actually, I think this one has, no, it has the same charge. So yeah, compare these two. They're also at different observed locations. I guess I could move the observed location for this one to have the same one as the other one, which was, I think it was 0, 2, 0, or 2, 0, 0. Let's see. Yeah, that's it. See, and it still has a similar deflection, even though it's the sum of the two electric fields. So, and they're both repelling, so I'm not entirely sure, but this is the answer.